So now, let's move on to the next one. So I'd like you now to do kind of the same thing we did with e to the x. I would like you to use your graphing calculator, and I'd like you to graph natural log of x, and then I'd like you to graph the derivative of it. And then let's just talk about what those things look like and talk about some restrictions that we do have. So go ahead, stop the video, use your calculators and graph these things and graph the function of e, or natural log of x. So go ahead. Okay, so let's now go back to our calculator. And notice I have y equals, oops, second. Let's get that off. Let's clear that. Let's go to y equals. And notice I still have my e to the x function, so let's clear those. And I'd like you to graph natural log of x. So let's graph it, and again, graph it in a standard window. And what you end up with is that. So our function goes like this. It goes through 1, 0, and then it just starts going off like that. Okay? Now, you can kind of figure out what the graph is going to do. I mean, because we could pick different spots, and then we can check kind of what the slope is. So like if we pick right down here, the slope is really positive. If I draw the tangent line, it's really positive. If you pick here, the slope is getting less. If you pick here and I draw the tangent line, the slope is getting even less. So what happens is it's really positive, then it gets less, and then it's getting less again. So your graph kind of goes like this. Well, let's verify that. Okay, so let's go to y equals, and now let's do the same keystroke. So go to math, go down to number 8, and let's graph the derivative. So let's do natural log of x, and then we have to use comma. Let's see, comma, x, because that's the variable that we're working with. And then we have to do comma, and then we want to check all x's. So we're going to put another x. So this is just graphing the derivative for us, and then let's go graph. And I'm leaving both of them on there now so you can just kind of see it. So now if you notice, this second one comes in from the top and it goes straight down and it gets closer and closer to 0. Okay? This is a very similar graph to something we have seen in the past. Okay? It does come down, and mine's a little wonky there, but it gets a little bit more like that. But it comes down and it looks like that. This is actually the graph of 1 over x. Okay? It's the graph of the reciprocal. Now, the thing is that we only use in our domain, x does have to be greater than 0 for the natural log function. So you cannot take a natural log of something that's negative. Okay? So we only focus on anything. This is our domain. Our domain for this function is anything greater than 0. So we only focus on this half. If you remember, with the reciprocal function, there also is that other half. This part is not included when we're talking about natural log. Okay? So let's go through and do some problems that involve natural log. So I'm going to do kind of the same thing that we did in the previous problem. Okay? And we are going to go through and try to calculate a couple of things. So if we take a look at this, I'm just double checking myself with everything that I have. Okay, so what we're going to do is we're going to prove that natural log of x equals 1 over x. Okay, so here's how we're going to do that. We're going to say y equals the natural log of x. So we're going to define our function as this. And we're going to slowly kind of morph it into something that we can work with. Okay? So the first thing we're going to do is we need to remember, in order to get rid of natural log, you can put e to something, and then e to the natural log is just whatever's there. So if we do this, if we take e to the y equals e to the natural log of x, what ends up happening is e to the y equals these two kind of cancel each other out, and it's just equal to x. Okay? So now, we are going to use implicit differentiation to get the derivative. So we're going to get y prime by itself, or dy dx. So if we go through and do this, remember in the previous one, this is an inside and an outside function. My outside function is e to the x. My inside function is y. So if I take the derivative, this is y prime. And then the derivative e to the x, of course, is just itself. So when we multiply this out, it's e to the y times y prime equals, and then the derivative of x is 1. Okay? Now, get y prime by itself. So divide by e to the y. E to the y. So here's what we got. We got y prime equals 1 over e to the y. But here's the thing. We need it in terms of x. And I want you to look at this list of stuff down here, and I want you to notice that we did find out what x is, okay? Or what e to the y is. What is e to the y? Well, e to the y is equal to or equivalent to x. So I can replace e to the y with x from there, okay? So this is just a quick little proof of the natural log of x function and where its derivative comes from. I just wanted to use it to show you how to, again, review implicit differentiation. It's always the same sort of thing with implicit. Take the derivative with respects to x, get all the e or the y primes on one side, factor out a y prime, and then solve for y prime. Okay? So let's take a look at two final things. And of course, these last two are just going to involve the chain rule. So with the chain rule, you have to remember that inside-outside function idea. So clearly, when you look at this, you can see there is an inside function, and you can see there is an outside function. So let's set this up. And again, any point in time, you can stop the video, try it yourself, and then follow the work. Okay, so my inside function is 2x plus 2. My outside function is the natural log of x. So here's what you have to remember. The derivative of the natural log of x is 1 over x. And then the derivative of 2x plus 2 is just 2. So go ahead and substitute that in. So we're going to get 1, so y prime. So let's make sure we do that because we have to take the derivative of that side. So the derivative of y is y prime. So it's over 2x plus 2. And then we're going to multiply that times 2. Now, you'll notice there's some simplification we can do. So y prime equals 1 over, first of all, I can take a 2 out of that 2x plus 2. And then it's going to be 1 times 2, so that's going to give me 2 on the top, right there. Okay? So when I end up canceling this out, it's going to be 1 over x plus 1. Okay? So always remember that factoring thing, you know, if you can. Because remember, when you multiply fractions, the 2 goes to the top, so you can factor out a 2. So it ends up being 1 over x plus 1. Okay? So now, let's take a look at our last one. Again, if at any point in time, you can stop the video, try it yourself, and then kind of move on from there. Notice, this is an inside and an outside function. So we're going to do outside and inside. So my outside function, again, is natural log, except my inside function now is the tangent of x. So with trig functions, you end up with, first of all, 1 over x for this one. And then tangent, the derivative of tangent, and you need to memorize all of these, people, is secant squared of x. Okay? So let's go through and let's take our bottom and insert this in there. So it's going to be f prime of x because we're taking the derivative of the function. And it's going to be 1 over tangent of x times secant squared of x, which then is equal to secant squared of x over tangent of x. And there is your derivative of that function. So this is the introduction to natural log and e to the x. I hope that it's helpful. I hope that you have learned something, and I will see you in class fairly soon. Have a great rest of your day, and I will see you soon. Goodbye.